6-2. Here we are on example 1. We are going to skip the critique and explain. This asks us, how are the diagonals of a kite related? The picture that we have to go with that is actually on the next page. So go ahead and look at that area. We know by the definition of the kite, if you look at the first page of your packet, that a kite has sides that are congruent. This one is congruent to this one, and this one is congruent to this one. The diagonals go from vertex across the shape to another vertex that is not next to it. So we're not going to count the D to A or the D to C. We will look at this other diagonal that goes from A to C. And we could spend a bunch of time on the Y's and proving this, but we're just going to learn that DB is the perpendicular bisector. If you prefer to use the symbol for perpendicular, you can. DB is the perpendicular bisector of AC. That means that this is cut in half and that these are 90-degree angles. All of those, they're in the middle. So using that information, let's do the try it. If angle AXB, that one is going to be 90 degrees. That is the measure of angle AXB. If AX, so this is 3.8, what is AC? The whole thing would be 3.8 times 2, which is 7.6. So the measure of AC is 7.6. That's the whole line. And if BD equals 10, does BX equal 5? And the answer is no. AC is bisected, but BD is not. So AC is the one that has the equal parts. BX and DX are not congruent. So we could say no. AC does not bisect BD. Let's go ahead and fill in the diagonals of a kite theorem. Of course, this is something that you may need to use in a proof, may need to use for your notes, so highlight it so it's easy to find. The diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. So you can draw in your diagonals and show that those intersect at 90 degrees.